And we'll just give it one more minute and then we'll get started. Okay, hello everyone. My name is Andrew Dion, and I'm a professional engineer working with WSP and representing CLF today. I'm here to introduce our monthly educational event. Today, we're focused on how to reduce the amount of embodied carbon in concrete. Concrete is one of the most widely used construction materials, so any amount of reduction of carbon will be a significant step forward in the right direction. Before we get started, I wanted to say a few words about the CLF organization. For those who are new to CLF, the Carbon Leadership Forum is a global network of over 5,000 members worldwide with representation from over 2,500 different companies in over 75 different countries. The goal of CLF is to accelerate the transformation of the building sector to radically reduce the embodied carbon in materials and construction through collective action. This includes pioneering research, creating resources, fostering cross-collaboration, and leading initiatives focused on bringing down the carbon footprint of our built environment. CLF Toronto, that's us, is the local hub of the Carbon Leadership Forum, and we are one of the 4 Canadian hubs, with the others being in Vancouver, Ottawa, and Calgary. We're always looking to expand our network, so if you're interested in becoming a member, please take a moment to go to our website and sign up. If you're not ready to become a member, but would like to keep apprised of our events, you can visit our website and sign up to our mailing list. Speaking of future events, please join us next month's webinar, where we will have Leadcore, Elliston, and Multiplex talking about reducing emissions during construction. Now, as a Toronto-based group, I wanted to acknowledge that the land we are meeting on is the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat peoples. Toronto is now home to many diverse First Nations, Inuit, and Métis people. We also acknowledge that Toronto is covered by Treaty 13 with the Mississaugas of the Credit. Okay, some housekeeping items. We ask that you keep your video off and keep yourself muted until the question period at the end of the presentation. But if you do have questions during the presentation, that's great. Please feel free to type them in the Q&A box. So without further ado, I'm happy to introduce our presenter today, Alen Keri. Alen is a professional engineer with over 18 years of experience working with concrete. He comes from the industry where, among other things, he specialized in mixed design optimization and specification review. He is now the Director of Technical Services with Concrete Ontario, where he oversees all of their technical initiatives. And from the conversations I've had with him, he is often working with concrete suppliers to help them navigate our low carbon concrete specifications. So welcome, Alen, and thank you for coming. I will stop sharing and you can take it away.
Perfect. Thank you very much, Andrew. I'm just going to share my screen. Oh, it looks like host disabled screen sharing. Try again. Yeah, it's disabled.
You can try that again.
Perfect. There we go. All right. Hopefully you can see my screen now.
Yes, I can.
Awesome. So again, thank you very much, Andrew. Thank you very much to CLF Toronto for having me present today. I want to provide an update on advancing low carbon concrete across Ontario. The ready mix industry has put a lot of work into low carbon concrete for the last 3 years or so. So today I just want to provide an update and keep things pretty honest on where we are as an industry and where we're heading in the next few years. So just a quick agenda overview. I will be looking at, what is low carbon concrete? Is there an official definition out there that specifiers and owners can actually relate to. Low carbon concrete update. What are we doing on the low carbon side? Talk about EPDs, their rollout in Ontario, their availability currently, and what the process is to get them. Specifying low carbon concrete is a big topic of discussion. There's been lots of specifications we've seen over the last few years. So I want to address that. Industry collaboration and resources at the end, just to finish things off. Now, when you look at what is low carbon concrete, there's lots of discussions. Everybody's asking for it. But in terms of an official definition, we currently do not have an official definition for low carbon concrete, which does create a challenge for the industry. If somebody is asking for low carbon concrete, there's no standardized way of actually supplying it. So it is something the industry needs to look at, and some progress has been made over the last few months. Without an official definition, a more reasonable term today is lower carbon concrete. So we are trying to optimize the mix designs for performance, but now we're also trying to lower the carbon footprint of those mix designs while still making sure that all the performance stays the same. Now, if you wanted some kind of definition, concrete produced with a lower carbon footprint than traditional mix designs while still meeting all the relevant performance requirements. That's a very simple definition, not something that you're going to see in specifications yet, but it is something that we're currently working on, not just here in Canada, but globally. So the Global Cement and Concrete Association, as well as the American Concrete Institute, have both released definitions over the last few months. So it's something I will present today just to kind of showcase where the concrete industry is heading. So when you look at the GCCA definition, which is the Global Cement and Concrete Association, they represent all the national associations on the cement and the ready mix side, as well as precast as well. And what they've come up with is a chart. So this chart here basically has cylinder strength on the horizontal axis. You have GWP values, which is basically the impact of your concrete on the vertical axis. And then they've created 7 bands of different levels of low carbon concrete. Now, the bottom band, AA, is near zero emission product. And that's something, we're all targeting towards by 2050. Trying to get to net zero carbon concrete by 2050 is definitely the goal. It is a global goal, not just here in Canada. But this definition of low carbon concrete is very interesting, something we're exploring here in Canada as well. And the way basically it's supposed to work, so you take this chart with these different bands, and then you look at a certain design strength, for example, in this case, 40 MPa. You transfer that over to your own chart on the vertical axis, and then you basically have a timeline on the horizontal axis of achieving net zero carbon concrete. So to give you just an example of how this would work here in Ontario, so if you look at this 40 MPa concrete mix design, so we've chosen here as the example without air, you basically would be at 326.25 kgs of CO2 per cubic meter, which is from the Ontario Industry Average Report. And then you're basically trying to develop some kind of timeline to get to that net zero target. So here's just an arc pattern. You can also have a linear relationship going down to net zero. And if you look at where we're supposed to be next year, which is 2025, around the 280.6 mark, which is reflected kind of in our industry average. So we are on pace to get there according to these numbers and according to this definition. This would be an approximate 14% reductions of the baselines that we indicated in 2021. So it does work for the 40 MPa. But the challenge is obviously analyzing all the other mix designs, looking at everything else to see if the chart makes sense in terms of the mix designs we have available here, and what is the progression that we need to achieve to get to net zero carbon concrete by 2050. So again, a good starting point. But some of the challenges with this definition, it doesn't distinguish between air and non-entrained concrete. So air and non-entrained concrete are completely different. They're designed differently. One has a higher impact than the other, and lumping them all together as part of one mix design will pose a challenge. Something else you might notice on the horizontal axis of the initial chart, it only goes up from 20 to 50 MPa concrete. Here in Ontario, we do regularly pour high performance concrete, 70 MPa, 85 MPa. So that would not really be reflected as part of this definition. It also doesn't really address additional performance criteria like classes of exposures. So classes of exposures are used to determine what type of environment the concrete will be put into. For example, is it going to be exposed to freeze-thaw cycles? Will it be exposed to sulfates or maybe chlorides, salts? So a class of exposure like C1 here in Ontario, which is structurally reinforced concrete exposed to chlorides and freeze-thaw, does have a permeability requirement, meaning that this definition wouldn't adequately really reflect the definition for Class C1 concrete as low carbon. So there's lots of challenges with this definition. It's a good starting point. It's also individual reductions per mix design. You're shooting for GWP targets instead of actually budgeting when it comes to carbon budgeting and outlining, different times of year. The mix design is going to change, etc. That's really a better approach when you're looking for carbon reductions. But again, it is a good starting point and something that was just released at COP29 a few weeks ago. So it gives the industry something to work with, especially here in Canada. Something else that was recently released is the American Concrete Institute Code 323, which is the low carbon concrete standard down in the US. Lots of work went into this. Currently, it is only available in inch and pound units. There's no metric conversions available. I'm sure they're going to be aiming for that in the near future. And they do have an official definition. So basically, concrete designed with reduced cradle to gate global warming potential compared to a benchmark and tier 1 requirements. So what does that actually mean? So when you look at the different requirements, they basically break it down by application. So they have BL1, which would be the tier 1, which is designed for buildings. So they have a specific requirement for buildings, which is based on gross floor area. Depending on the size of the building, there may or may not be a requirement for low carbon concrete, and I'll give an example in a second. Then they also have PH1, which is pavement and hardscape. Now, this requirement is based on concrete volume. How much concrete are you pouring? And dependent on that volume and the size of the project, there may or may not be a low carbon requirement. BR, which is bridges, it's focused on the deck area. So not the gross floor area, not concrete volume, but the actual deck area of the bridge. And then STR, which is structures, again, based on concrete volume requirements. So basically, this breaks down to charts such as these. So this is the chart for the building requirements. You can see here, this is tier 1, BL1. So anything greater than 50,000 square feet will have a low carbon requirement. And the way it basically works is the project average in GWP has to be less than alpha times the benchmark average. Now, the alpha in this case has been defined as 0.85. So basically, you're trying to achieve a 15% reduction on your project compared to the benchmarks. And the benchmarks are dependent on regional information. So these are GWP benchmark values that were established for Eastern US, so region 1. So you're looking for 15% reductions for different mixed designs based on these values here. If you see BL2 on the left side here, there is no requirement if your building currently is between 50,000 square feet to 5,000 square feet. And then BL3, anything less than 5,000 square feet, there's also no requirement. But as was indicated in the previous slide here, requirements of the code are anticipated to become more stringent in future editions. So this is just a starting point, something ACI is looking at. Can this be implemented? Is it reasonable? Is a 15% reduction reasonable from the currently indicated benchmarks in the US? So it's a different approach than what the GCCA is looking at by using a chart and different bands. And this is something that could work very well here in Ontario. So it does use a project carbon budget. So you're basically taking all your mixed designs, you look at their baselines, you multiply by the volumes, you come up with a benchmark value for the CO2 emitted. You do the exact same thing for the actual concrete shipped, where you're trying to achieve a reduction. You compare the two, and hopefully that reduction is more than 15%. Now, we do have our own regional report here in Ontario, which is this report, the Concrete Ontario Member Industry-Wide EPD report. It was published in 2022. So we do have baselines. We do have the information available that could be used in a similar fashion as this ACI code, but it does need some tailoring to figure out, building structures. Are we going to have the same approach? Now, the alpha in this case, 15%, is fairly reasonable from what we've seen in the industry here in Ontario as well. And we recently formed a sustainability committee to potentially look at releasing a definition in the near future here in Ontario. And we will consider, GCCA definition, the ACI definition, and see how we can adapt that to the Ontario market to make sure it makes sense, that it's achievable and consistent you know, as we progress to that goal of net zero carbon concrete by 2050. So there's lots of work that's going to be going into this, and hopefully we can provide an update in the near future on what the official definition of low carbon concrete will be here in Ontario. Now, providing a low carbon concrete update, what have we been working on? Where are we currently in the industry? So one thing I wanted to point out is the usage of GUL cement. It does have up to 15% limestone replacement compared to the type GU cement, which is slowly being phased out in Ontario. The type GU cement only allows up to 5% limestone. So this automatically gives you a reduction of up to 10% compared to the previously used type GU cement. So there really should not be any specification limits when it comes to the adoption of GUL cement or PLC cement. In Ontario, we're using approximately more than 90% usage already. There really is not a lot of type GU cement available. So limiting it anyway when it comes to specifications is counterproductive because the majority of producers in Ontario are using GUL cement. So that's something I wanted to point out here. There's also ongoing research right now with the University of Ottawa as well as the University of Toronto to push that 15% limestone content to 20% and even 25% to again have a lower carbon cement available here in the industry, which again will lower your impact of the concrete that's being provided. So that's all very positive. Now, slag is still the primary SCM or supplementary cementitious material that we are using here. It is readily available. We haven't really heard of any shortages. So low carbon concrete, is not really being hindered right now by supply chain shortages, which is great. And we're also looking at, different SCMs to get the carbon footprint down. Anytime you replace your GUL cement with an SCM, you are lowering your carbon footprint. So the more SCMs we can use, the better low carbon concrete we can achieve. Now, members or producers in Ontario are also looking at harvested fly ash, which is being used out west in Alberta especially. It has been used there for numerous years. It's proven to be used very effectively. And basically, that's from the coal industry. It's all the fly ash that was buried many years ago. It's being dug up, it's being refined, and it's fully you can fully replace your GUL cement with it. Something else we're seeing is ground glass, something that's being used in Quebec today already. It can replace a certain amount of GUL cement and again lower your carbon footprint overall. So these are two exciting SCMs that we're welcome to using here in Ontario. But again, there are challenges of getting it here, especially the fly ash from out west. Ground glass is primarily used in Quebec. The production rate, is not there yet, maybe. But there are options that are coming in the near future to replace slag and give us options to, again, lower carbon footprint even more. Admixture companies are working tirelessly to come up with new products, not only to compensate for GUL cement performance, but also to lower carbon footprint. So they've put a lot of work into, not just producing super plasticizers and water reducers. They now are targeting very specific products that are allowing you to lower your carbon footprint by optimizing your mix designs. So that's very positive there. And they're continuing to work with many ready mix producers in the province to not only optimize performance, but also get that low carbon concrete requirement that a lot of specifiers are asking for already. Now, continuing the update, now, depending on time of year and level of low carbon concrete that's required, the schedule may be impacted. The more SCMs you use, the slower your hydration rate. The concrete takes longer to set. It takes longer to gain its strength. So that's something that needs to be discussed at the project phase, the project schedule phase, especially. It may delay your schedule, but there's also adjustments that can be made. Again, the admixture industry does have non-chloride accelerators to accelerate the set. You can optimize your schedule by pouring maybe some of these lower carbon elements in the summer and really jacking up the SCM contents. And then you can take a hit a little bit in the wintertime as your schedule changes. So lots of discussion needs to be had on what level of low carbon concrete you're looking for, and what is your project schedule, and is it achievable? Ellis Don has done a really good example, really done good. Ellis Don has done a really good job of asking for different levels of low carbon concrete and seeing the impact it has on their projects. For example, they're asking for, your typical concrete. What is the impact? They're also looking at cost, which is not something that we get into. Then they're asking for a lower level, low carbon mix, which now gives you better carbon reductions, with an associated cost. And they're also looking at the lowest possible level of low carbon that's available, which may have an impact on your schedule, and they're factoring that into their project. So looking at different levels of low carbon will allow you to really determine what's available, from different producers, but it also allows you to maximize your schedule depending on the time of year that you're starting your project. Now, something else I wanted to point out, high performance concrete, once you get into the 50, 60, 70, and 85 MPa concretes, which are routinely poured downtown Toronto, it may be difficult to achieve carbon reductions. These mix designs are already optimized to use higher SEM values because they're designed for higher strengths. So it takes longer to gain those strengths, and you also need the SEMs to get you to those strengths. Using purely GUL cement most of the time will not get you there. So SEMs allow you to gain that strength long term. Takes a little bit longer. So because you're putting in more SEMs into these higher strength concretes, it may be difficult to achieve higher carbon reductions because, again, they're not designed just for strength and durability and permeability. They're also designed for performance, not just low carbon. So one example of that is Class C1 concrete, which is your structurally reinforced concrete exposed to chlorides and freeze thaw. It has a permeability requirement. Basically, it has to resist those chlorides that it's going to be exposed to. So if you look at our Ontario industry average report, you can see that this mix design was designed, the baseline was at 25% slag. So achieving a greater reduction for C1 concrete can be a challenge, especially if you're pouring this concrete during the wintertime. Shifting it down and using more SEMs will lower your carbon footprint, but it will increase the set time. So achieving, potentially 20% from your current baseline can be very difficult as you're already using 25% slag to achieve those performance requirements I indicated previously. So something that needs to be considered if you are targeting, high carbon reductions for high performance concrete, you need to look at first achieving the performance, the higher performance, those 85 MPa strengths, and then factoring in how much more SEMs you can use to lower your carbon footprint. So that's a quick overview of where we are as an industry when it comes to low carbon concrete. Again, schedule, it will be a problem on certain projects depending on what you're starting, but there are solutions, and specifiers and owners are, encouraged to reach out to ready mix producers to see what the solutions are. When it comes to EPDs or environmental product declarations, those little nutrition labels for concrete that tell you the impact, which I basically just showcased in the previous slide. We do have the Ontario Industry Average Report, which was published in 2022, and it is valid for 5 years. So this should be a starting point for all specifiers looking to reduce your carbon footprint. Baselines are indicated in this report. We also outline over 20 different mix designs and their impact from an industry average standpoint. But again, this report is only valid for 5 years. So we're already looking ahead. How can we optimize this report? The previously issued report from 2017, which was a national report, did expire on January 6th. So it should no longer be used for carbon reduction goals. The baselines there should not be used either for carbon reductions. Something I want to point out because we are still seeing them pop up in different specifications. So using the regional approach is the way to go, and it is valid until July 27th, 2027. Now, the baselines are definitely a good starting point for carbon reduction goals. They were developed back in 2021 when GU cement was still prevalent, and at that time, this was the best solution for the baselines. Obviously, now we've slowly transitioned to GUL cement, which will improve the baselines, and it's something we're looking at. So our sustainability committee is looking at providing more baselines, addressing things such as UFill, which is a 0.4 MPa concrete, pump prime, which doesn't have any coarse aggregate, grout. These are all one-offs that need to be addressed so you can properly, set your carbon reduction goals and actually monitor them. But there's a lot of discussions on what's going to happen with the baselines. Are we going to be switching all of them over to GUL cement? Do we keep the baselines the same right now as they are right now with GU cement and ask for larger percentage reductions? So again, lots of discussions that we're having internally because we will have to have a new report ready in 2027. But as of right now, minimum 10% reductions are highly advisable. That is what the standard embodied carbon in construction standard showcases right now, and something we worked on with the Treasury Board. But greater reductions are welcome. So if you feel like you want 20% reductions from the baselines, 30% reductions, they are welcome. It's just that ready mix producers should be consulted. They have better information. They have type 3 information available, which I'll get to next. And you can ask for that information today to see where each individual producer really stands and what reductions are achievable. But from an industry standpoint, we are advising minimum 10% reductions from the baselines. Now, the majority of ready-mix producers in Ontario are aware of EPDs. We've spent the last 3 years educating our members. We do represent 96% of the ready-mix producers here in Ontario, and we have been connecting our members with sustainability consultants. There's WAP Sustainability, Climate Earth. There's several others out there that offer the same services, but we've been connecting our members with these consultants to learn about EPDs, to figure out what they need to do to get EPDs. So there really shouldn't be any surprise that EPDs are being required these days, and they definitely are a key to setting and achieving carbon reduction goals. So Concrete Ontario is, we heavily support their use, and it's only going to get better as other materials get to the point of having EPDs as well. Now, the industry average report is a great start if you don't have any other information, but type 3 EPDs, which are facility specific, so basically an EPD from a very specific plant in Ontario, a very specific producer, that is the most accurate information, is also third-party verified. So here's just an example from the EC3 database, Toronto Ready Mix, type 3 EPD that's readily available that anybody can look at, and it was published by Climate Earth. They are available and they should be asked for, but you can always lean back on the Ontario Industry Average Report, which does give you a starting point. The challenge with type 3 EPDs is that they're material specific. So if you do have any shortages of materials, your supply chain challenges, for example, it will impact your overall data. So type 3 EPD does have to be redone if a material change does occur, especially your cement, which does have the highest impact. So cement is typically 7 to 15% of a concrete mix design, but it counts for about 85% of the concrete's carbon footprint. So changing your cement source will definitely impact your EPDs. And that's something that specifiers need to keep in mind because their project runs for a few years at a time. Something else that potentially we're talking about is if your EPD does change to a certain amount, let's say you change your aggregate source, you change a different source, anything but cement, and the change is minimal, do you have to redo your EPD? Do you have to republish that EPD, or can we implement some kind of system where a tolerance would be allowed? If there's less than a 10% change from what you currently have to what you're moving to, do you have to republish those EPDs? There's a cost associated with all that. So something that, again, we need to look at as an industry. And something else we've been made aware of is there's a 3 to 6 month lag in getting type 3 EPDs. So we've been in a lot of conversations with our members saying it does take time to get this information. So if you're seeing tenders, especially in Northern Ontario coming through that have low carbon requirements that are asking for EPDs, it's not something that you can get very quickly these days. So it's very important that everybody's aware of what are EPDs, how do you get them, what's the cost associated, and keep in mind that you can't get them tomorrow. It does take time. So that's a quick overview of EPDs and where we are as an industry. Again, readily available, type 3, the most accurate, but the Ontario Industry Average Report is a starting point. Now, when it comes to specifying low carbon concrete, there really is only one standard that we've really adopted and something that we've been promoting as an industry, not just here in Ontario, but across the country. It's a standard embodied carbon in construction from the Treasury Board. It is part of the greening government strategy. Now, this has been in place for a couple of years already. As of December 31st, 2022, any project, government funded project, $10 million or more, or 100 cubic meters, which is basically all of them, has to have EPDs. So their language is the highest resolution EPD available. So basically, product specific, which is your type 3, or even the regional average in that order. Again, something that we worked closely with the Treasury Board, and it's definitely a requirement that we want to promote to all specifiers. Now, as part of this standard embodied carbon in construction, there's also a proposed requirement for reduction. So basically, the total project GHG emissions from ready-mix concrete shall be at least 10% less than those calculated using the GWPs of the baseline mixes in the regional industry averages. So basically 10% less than the baselines that we indicated in the Ontario report. The other provinces across the country, there are 7 reports that are available. They would be able to meet this exact same requirement because, again, they have their own baselines depending on the materials that they're using. As mentioned previously, Alberta does have a lot of fly ash, so their EPD report would reflect that. They wouldn't use as much slag as we do. So this is a great starting point for any kind of carbon reductions here in Ontario. Anything greater than that should be discussed with the ready-mix producers through EPDs, very easily determined. From a design standpoint, you can determine that very quickly if you have type 3 information available. But we are advising everybody to follow the standard embodied carbon in construction and consider at least a 10% reduction from the current baselines. Something else the Treasury Board did a really good job of, and something that we were very happy with from a collaborative standpoint, they recognized, the changes in the concrete mix design, as you pour it in different times of year. So concrete is basically a changing material depending on when you're using it. A summer mix design would not be the same as a winter mix design, and that all creates changes in the EPD. So something the Treasury Board was able to provide is recognition that if you are using a specialized concrete such as high early strength, higher ultra high performance, or cold weather applications, that the baselines in the regional reports can be increased by 30% to account for that. This is just a starting point as we get a bunch of projects, through the entire design and construction stage. We know this 30% is going to go down as we get more data in, but it's great to see the collaboration that we were able to achieve with the Treasury Board to recognize that our product is different from any other product. For example, steel, the impact of steel will not change when you get the product delivered on a daily basis. Our product does. So there's additional challenges that we have to deal with, but there's also lots of flexibility for the contractor. You can change the mix design depending on placement type, time of year, etc. So again, this is a great starting point for anybody considering carbon reduction goals. It's already established and something that we heavily support here in Ontario and across the entire country. And it's great to see that this is being adopted, at different levels. So something, we're seeing is the City of Toronto and their procurement policy, which is going to be released in the next few weeks. They're releasing the Embodied Carbon Management Toolkit for municipalities. And they're also asking for, type 3 EPDs were available, otherwise referred to the Concrete Ontario industry-wide EPD report, which is, again, in line with the Treasury Board, in line with what we want to see. And they're also asking for a minimum 10% reductions below the baselines, similar to the Treasury Board. So ensuring consistency in carbon reduction goals is definitely a challenge. This is what the industry wants to see. It is achievable, not only here in the GTA, but also Northern Ontario, Western Ontario, and Eastern Ontario. So consistency and having the same requirements is key. We don't want to be moving the goalposts before we establish what is achievable. If you ask for 30% reductions, but at the end of the project, you don't hit that, then is it really valuable for a project? Being able to achieve it and then moving the goalposts is definitely key. So great to see the City of Toronto. We were able to offer some input here with Mantle Developments as well. So keeping things consistent is all we're asking for. And the city of Toronto has done a really good job of really, keeping things consistent. Now, something we're looking at to do as soon as this is released, we're creating our own little document, Concrete Change. We're working with the municipal engineers as well as the Cement Association of Canada and Good Roads. We want to promote this to all municipalities in Ontario to keep things consistent and achievable. And that'll ensure that everybody is on the same page. But we are still seeing a lot of specifications for projects that have lots of prescriptive requirements that are handcuffing producers from achieving carbon reductions. So here's a recent project. I just pulled out a little snippet here from their standard. So they're basically asking for a minimum overall project reduction of 25% in GHG emissions, according to the Concrete Ontario industry average report. So 10% is advisable. They're asking for 25%, which again can be achieved as long as you have the right information. But then you go down the spec a little further and it says, do not incorporate fly ash or slag into concrete mix designs without prior approval in writing. Now, I just talked about the importance of using SCMs to lower your carbon footprint, to replace that GUL cement and get the carbon impact down. And here's a spec in 2024 that basically prohibits the use of fly ash or slag, which is completely counterproductive to what we're trying to achieve here with the 25% reduction. Unfortunately, a lot of specifications are copy and paste. They have been for decades in our industry and something that's very difficult to get ahead of. But hopefully, we can implement that Treasury Board requirement on more projects. And we're not going to see requirements such as this, which basically are counterproductive and not achievable. That's just one example. Here's another example of a recent specification, which is related to shotcrete. Perform life cycle assessment for mix designs to ensure minimal environmental impact. That's great. But then you're basically indicating minimum cement content, shall be 500 kgs per cubic meter of concrete. So you're basically handcuffing the ready mix producer. They have to use 500 kgs per cubic meter, which already has an associated carbon footprint. If you ran the EPD for this mix design, it would be very, very high. There's no opportunity for the ready mix producer to optimize this mix design. This is what you have to use. It is highly prescriptive and, again, counterproductive to achieving any kind of carbon reduction goals. So unfortunately, this is still occurring in the industry. We want to move towards more performance-based specifications where you're allowing the ready mix producer to meet your performance, for example, indicating I want 40 MPa, I want 50 MPa at 56 days, allowing the ready mix producer to use all the available materials and resources they have at their disposal to give you the performance you're looking for, but also the optimal carbon reduction for that mix design. Using admixtures, optimizing the SEM percentage. In this case, it's minimum cement, not cementitious materials. So you have to use 500 kgs of GUL cement here. Again, not what we want to see in specifications for low carbon concrete. So that's just something we're seeing in terms of specifiers. And again, there is a clear outlined pathway forward when it comes to Treasury Board requirements. The City of Toronto is adopting it. Let's keep things as consistent as possible. Let's set the groundwork for achieving carbon reduction goals. And after that, we can start increasing the percentages to what they should be, at this time in Ontario. But something that we've noticed a lot over the last couple of years, especially myself having reviewed numerous documents, we need a lot more industry collaboration. Every material does have its place, whether it's concrete, steel, mass timber, etc. Every product has their own advantages as well as disadvantages, but every material is important. The majority of buildings in the future will be hybrid buildings, which is what we're seeing already, a combination of all three materials. So what I'm asking today is that we need more industry collaboration, whether it's sustainability consultants, owners, specifiers. We all need to come together to provide better information for the industry and not really targeting material, but allowing everybody to provide the most accurate information. And where I'm going with this is we've seen a few documents lately that are impacting, the quality of information that's available and the way that information is presented to the industry. So this was a report that was published in 2022, around the same time that our Ontario Industry Average Report was published as well. And it's for residential concrete for GTHA, which is the Greater Toronto Hamilton area homes, analyzing the carbon impact of concrete for GTHA homes and outlining basically, the concrete is a major contributor to CO2, approximately 32.9% of a house, etc. Or here it says 33%, same thing really. But then when you look at the data, you look at the report or where the information is coming from, and is it accurate? Is it the latest information available? It becomes pretty evident that somebody should have reached out. We should have had more collaboration when it comes to the industry. Concrete Ontario and the other associations across the country, as well as the Cement Association, are always available to provide input on any kind of document. And seeing a document that, goes against concrete by using wrong information is not what we want to see. Again, we're not trying to bash any other materials. We want the most accurate information to be reflected. And it's important to reach out and get the latest information before publishing any kind of report. So basically, this report in 2022 looked at the EC3 database, which does have a lot of EPDs. It pulls them from the internet. And it looked at 0 to 25 MPa concrete from Canadian manufacturers. So even though this report is intended for GTHA homes, none of the information that's available in EC3 at that time was from Ontario. It was outside of Ontario, but the report still went ahead and basically did the analysis for the concrete with information that was available at the time. Now, I mentioned that this report was released around the same time as our Ontario Industry Average report. So the information that was there for Ontario, and it is something that we could have collaborated on. But the concerning part is, GWP for 25 MPa concrete ranged from 93 to 828 kgs of CO2 per cubic meter, which is absolutely crazy. There's not a single mix design from 0 to 85 MPa that I've seen that is this high. So there's definitely something wrong when it came to that mix design. And then EC3 calculated an average of 390 kgs of CO2 for Canadian concrete for those 25 MPa mix designs. So if you look at the chart that was actually used for the report and you kind of browse through it, and again, collaboration would have been definitely helpful here. You look at Butler Concrete, which is based out of Vancouver, a very low impact, 124 kgs of CO2 per cubic meter. There's some Lafarge mix designs in here. The CRMCA report, again, expired January 2022, so it was no longer valid when this report was published. It combines 107 Canadian 25 MPa concrete EPDs and basically says the average is 390, with the most conservative 25 MPa being 507 kgs. And there's this one Lafarge mix design here showcasing 610. Now, what I'm trying to say here is this information is not accurate. This information does not reflect your residential concrete here in Ontario. And it's a report, that should have been peer reviewed by our industry, perhaps. But the worst part of it all is, analyzing, data that's not valid. So basically outlining that at worst, 0 to 25 MPa concrete with a higher GW factor of 610 kgs of CO2 would raise the concrete emissions for houses in the study by this many tons or 100% increase. Now, this sends the message that concrete is not sustainable. It sends the message that basically residential concrete is 610 kgs of CO2 per cubic meter. And again, we're nowhere near that. And it's something that needs to be considered when you are putting together a report. And the other concerning thing is this data influences other statements, such as, the promotion of treated wood foundations, or even, minimizing the use of concrete for any kind of below grade construction, because the report highlights that the carbon impact is very high based on the available information. So when you actually look at putting together the proper information for this report, we reached out to ResCon, we collaborated, we put together a report outlining that the majority of concrete in Ontario, when it comes to the Ontario Building Code, is 15 MPa, which are your footings, which are your foundation walls. The interior slabs on ground can be 20 MPa or 25 MPa, but they're nowhere near the 390 kgs, the 610. These are the true values. So, 200 kgs is pretty common CO2, but it can go down to 150 kgs of CO2 for lower carbon versions of the same mix design. So having the most latest information available is definitely critical when you are putting together any kind of document. And all we're asking for is that the right information is used. If it's not available, please reach out so we can supply you with the latest information here in Ontario. And another report I want to kind of criticize a little bit is this study of exit stair and enclosure construction types, which was just published a few weeks ago. It compares different materials, which again is fine. It is happening a lot today, comparing concrete with masonry, with steel stud and wood and CLT, etc. I did say previously, every material does have its place, but the information needs to be correct when you are putting together the actual report. So for the concrete side of this report, 35 MPa and 45 MPa concrete were both used from a cast in place perspective. And you dig into the report and they basically use the baselines without air entrainment from our 2022 report. Now, these baselines were valid back in 2022 when we established the report, but this is not the concrete that's poured today. I already mentioned we're already on 100% GUL or 90% GUL usage here in Ontario, meaning that these values are inflated. And for a report that was just published a few weeks ago, there could have been a lot more collaboration with the industry to give you proper information on what the current 35 MPa without air entrainment consists of, what is the impact of that mix design, and what should be used, what is used commonly across the industry. So basically, here's the numbers that were used. Again, baselines from 2022, which are applicable. But when you look at where we are today, we're already over here. So, that's at least, around a 10% reduction. And, more commonly for those type of applications, having lots of experience in mixed design formulation, we're probably closer to here, to 254 and 300 kgs of CO2, which is, savings of almost 50 kgs of CO2 per cubic meter, which is quite significant. So having the right information available to put together reports is definitely critical, but ensuring that each material gets a fair, share of the information, a fair assessment when it comes to classifying it in terms of carbon reductions is definitely something we're asking for. And that's not just us, that's every other industry. So lots of resources are available. We spent a lot of work developing information. We put out this concrete carbon document in 2022 here in Ontario. The other provinces have adopted it as well now as of June 2024. There's lots of case studies. There's a lot of talk about carbon budgeting in there and the impact of low carbon concrete. How do you achieve it, etc. So reviewing this information is definitely helpful. And again, we encourage, if there's any questions, to reach out and ask any further questions. But there's not just bad documents being put out there. There's lots of productive documents. This is one of the best ones I've seen when it comes to looking at concrete. So a pragmatic approach to lowering embodied carbon. This was ZGF, Fastenep, Elliston, and Lafarge out of BC that put this together. Really good document outlining pre-design all the way to construction administration and beyond of what you need to consider when you are looking at low carbon concrete. So having this available, I think will really give you a better understanding of where we are as an industry and how to move towards using more low carbon concrete. Other resources that we're offering, we've changed our fundamentals of concrete course to fundamentals of sustainable concrete. So we're running a course in March. If you do want to learn more about low carbon concrete and what it actually is and what is available here in Ontario, this is a great 2-day course. The ACI convention, concrete convention, is also here in Toronto in March. This convention comes here every 10 years. So this is a really good opportunity for anybody interested in learning more about concrete. There's lots of low carbon concrete topics being covered, lots of research being conducted, which is very fascinating. And it's going to allow us to lower our carbon footprint. So I encourage you to check that out. And the last thing, really, we are looking to host a low carbon concrete symposium on April 16th in the GTA. We're going to be showcasing the best the Ontario ready mix industry has in terms of innovations and products when it comes to low carbon solutions. We're also going to be collaborating with external partners, potentially Kirkor Architects, and some other groups to ensure that we're getting the message out there and we're collaborating to give everybody the best possible information. So we will be releasing more information in the coming weeks, but we definitely encourage people to attend and learn more about low carbon concrete. Okay, and other resources, sustainability again is a major initiative for Concrete Ontario. We do have our sustainability committee, which is looking at numerous aspects, including a definition for low carbon concrete. We can always do lunch and learns and presentations. We offer complimentary specification and document review if you want any kind of feedback on what you're putting together that is using our information, especially the Ontario Industry Average Report, which we put together and we will be updating in 2027. We're always willing to share that information and give you guidance on what should be used today and what makes the most sense. So again, not to bash anybody when it comes to document creation, but please reach out. We're available. We're always willing to help to make sure that the most accurate information gets out there to, construction associations, home builders, etc. Solutions are available. This isn't the old concrete that we've been using for decades. We are making lots of progress to get to that net zero carbon goal by 2050. And there's going to be challenges, but at the same time, collaboration is definitely key. And we look forward to working with more specifiers, owners, municipalities, etc. So that's basically all I have for you today. Thank you very much for tuning in. And I'll gladly take any questions that may have popped up since I started presenting.
Thank you very much, Alen. That was a great presentation, a very good update to where we are in the industry right now. We do have one question in the chat regarding the percentage reduction recommended by institutions like GCCA, ACI, and the Government of Canada. Are we seeing any alignment with SBTI's reduction pathways for embodied carbon?
What is the SBTI, standard body?
Heather, do you have insight onto that?
I don't know.
I think it's the science-based initiative, science-based. Yeah. It's a
science-based targets.
Yes.
Science-based targets.
Yeah.
There is no current consistency, unfortunately, in anything right now. I think we're too early on and we're trying to achieve that consistency between ACI, GCCA, and here in Canada. It would be great if everybody had the same reduction goal to start. We know there's obviously, higher percentages are achievable. There's no question, right? But if we're not starting things off uniformly across the entire industry, we have different municipalities asking for different requirements already. We have different specifiers. We've seen reductions up to 50% from the expired report that expired in 2022 being asked for today for a major hospital project. So it would be good to get some kind of alignment. 10% we feel like is a great starting point. Does it fully reflect low carbon concrete? No, but we are working, this is a long-term process. It's a marathon. We're trying to get to 2050 and hopefully achieve our goal. So there's really no rush in pushing the industry too fast.
Thanks. There's another question. Are there any initiatives that are looking into recycled concrete?
Absolutely. So Good Roads actually is doing a research project with the National Research Council. Not only are they looking at recycled concrete aggregate, they're looking at RAP for asphalt as well. They're trying to basically indicate to NRC where's the possible stockpiles for RCA. And CSA that was just published in July actually allows 30% RCA back into concrete, depending on where it comes from. Obviously, return concrete from a ready-mix truck is the best, cleanest version. There's also demolition waste that can be ground up and used back into concrete. Our RCA is definitely critical, especially if you're going to be tearing down buildings in the future. You can recycle all that concrete. But it's really identifying clean stockpiles that can be used consistently. I think that is the hardest part right now. We don't want to compromise the new concrete by using, inadequate RCA. So I think ready-mix producers are hesitant to some level to use too much of it, but it is heading that way. We're identifying stockpiles and we're encouraging, municipalities and specifiers to start incorporating that as part of their standards.
Do you think that more testing is needed in order to give confidence to the ready mix suppliers that it's usable?
Testing is definitely encouraged, but I think it's a stockpile issue. Because if you look at a lot of ready mix plants, they don't have the space to actually do this. Especially the ready mix plants, downtown Toronto, space is very limited. There's lots of return concrete where, we initially, when we did our report, the EPD report, it does consider around 5% return concrete. We're seeing it's higher than that. It's about 8 to 12 to 13%, depending on the plant. So having the space to actually do this properly is definitely very challenging. And if you don't have the space, because it needs to sit there, it needs to harden before you bring in a crusher, it's a lot of dedicated land that is not available at a lot of plants. So that's definitely a challenge. And then again, consistent return material is the other challenge. So you can do a lot of testing, but if the return concrete will vary where it's coming from, it's still going to be a challenge to put it back into new concrete.
There's another question here. So maybe a big one. So there's 25 years to go to get to net zero. How are we going to reach this target?
That's a great question. And that's part of the Cement Association roadmap to net zero. One of the biggest factors in there is carbon capture, utilization, and storage. So, the production of cement, that's really where your carbon emissions are coming from. 1/3 of it is from the fuels used. So the cement industry is looking to change their fuels, basically burn garbage, burn tires, etc., to reduce the carbon impact of the fuels. But the emissions themselves, when you actually heat the limestone, that's where 2/3 of the emissions come from. That's something that needs to be controlled. So carbon capture, utilization, storage would capture all those emissions. There's a great pilot project out in Western Canada, in Edmonton, with Heidelberg. They were just given $1 billion from the federal government to basically run a pilot project and capture all the CO2 from the emissions and then basically inject it into the ground where it would be permanently stored. So if you're able to achieve that, the cement impact would become very minimal, and you're able to achieve very low carbon concrete at that point. Now, that's a pilot project that's possible out in Alberta. Is it possible here in Ontario? Very difficult, right? When you look at the pipeline network that's required, etc. Also, the investment, $1 billion is a lot of money. So as more, I think, cement plants change their operations and more funding is available, and we really ramp up carbon capture, utilization, and storage, the roadmap does indicate, I believe, 28% is required for us to get there. You're going to see a lot better cement and, in turn, a much lower carbon concrete.
So, Alen, I've heard you loud and clear about the 10% reduction as a sort of a kind of a good target to start with. Now, for projects that are trying to be more ambitious than that, do you have any advice for projects that want to push this to try to show leadership in this carbon reduction?
Yes, again, going back to the collaboration stage, reach out to ready mix producers wherever your project is. You will have a handful of producers available. Obviously, in the GTA, there's lots of them. You can reach out, you can ask for type 3 EPDs if they're available, and you can see what each ready mix producer is able to offer. So if you use their type 3s to analyze, your project, what type of mix designs you're going to be using, the volumes of each mix design, and then using that type 3 EPD information, comparing it to baselines, you can really see where your project's, going to trend, right? Obviously, schedule will still play a major factor. But having that type 3 EPD information is definitely critical. It gives you, much more accurate information. And again, the EPDs in the Ontario Industry Average Report are inflated at this point. That report was published 2 years ago. Since then, better cement EPDs have been published already. So cement is getting better. But asking for EPD information and seeing what your project's able to achieve will allow you to go beyond 10%. I'm just not sure what is achievable. It really depends on your project schedule and the type of project you're doing.
Great. Well, thank you very much, Alen. I see that we're just past the hour, and yeah, just really appreciate your presentation. That was a lot of great information. So thank you very much. And for everyone else, please remember to sign up for next month's presentation. And until then, have a good rest of our Christmas break.
Thanks,
Thank you very
Alen.
much.
Thanks,
Take care.
Andrew. Bye.